balancing chemical equations algebraically. I'm Margaret. I wanted to illustrate a point I made earlier about which equation you use to plug into another equation for the substitution in finding the coefficients. I'm running out of memory, so I'm going to talk fast. So I have, again, water, H2, oxygen and hydrogen being the diatomic atoms, producing water, which is not the diatomic atoms, and some molecule over there. Well, I guess two of these guys would be a molecule. Anyway, I assign variables to each part of the equation, B and C. Now, here I take hydrogen to A equals to C. And here I take oxygen to B equals C. Now I plug, having C, I plug C into the first equation. I get 2A equals 2 times 2B, producing 2A equals 4B. I already have 2A in terms of C, so I get 2A equals 4B equals 2C. Now I could factor through here, and it would give me A equals 2B equals C. Taking the inverse, I get 1 over 1, 1 half, 1, get rid of the fraction, gives me 1, 2, 1, and 2. Now here, I don't do that, I take the reciprocal, 1 half, 1 fourth, 1 half. I then get rid of the fractions using 4, and that gives me 2 equals 1 equals 1, 2 rather, and that produces A equals solution 1, B equals, that's 2, 2, 1, and C equals 2. Now I get 2 and 2, 2 and 2 is 4, 2 and 2 is 4, and 2 and 2, 2 and 1 rather is 2, and 2 and 1 are 2. It balances. And again, that's the reciprocal on the last step there. And these are the diatomic molecules. One other thing I wanted to say is that if I was programming this, I would probably keep the numerator and the denominator separate, maybe reduce them as best as I can, and keep them separate.